Good afternoon and welcome back to the Workbench. So today I'm just going to do a little video on this preamplifier, which I previously made a video sort of about in relation to this power supply which I designed for it, in which I did a video like on KiCad and how to make a board in KiCad basically, and I used this power supply as an example, and I wanted to use that to power this preamp, with the idea that I could use it to connect my cell phone to my stereo and not have to adjust the volume levels and all that all the time. And of course you also avoid the issue where you need to turn your phone volume all the way up and turn your stereo up more than usual, and that sort of thing seems to be the case when plugging in something with a headphone jack. And then inevitably when you go to plug something else in, you blow your head off because everything is turned up so loud. So yeah, so the idea was to avoid that problem by just having a preamp, which would then allow me to keep the volume of the phone at the same level that I would with headphones, and then keep the amplifier volume control set down to the normal level I would when using my computer or CD player or anything like that, with a line level output, because this is not line level, it's much lower. It's these things run off a 3-volt battery or whatever or so they can't really output a huge voltage or that as you would have out of a CD player, for example, like a mains powered device or whatever. So it is kind of a problem. So yeah, so I had this little kit here lying around. It's just a sort of generic / universal preamp kit thing, based on the LM833 op amp and a bunch of other parts. It was a Dick Smith kit that I bought years ago, and I had the idea of using it for a preamp for a tape deck head. I wanted to sort of build my own tape deck. It was some thing that I had, this idea, but it never happened, and this just sat around doing nothing. But I had bought this, and I thought, well, this will be perfect to do what I want. And as it is now, I've done some modifications to it, and it is working pretty well. But as it stood, just the way they had it from here, wasn't perfect at all, and there was definitely some issues with it, and there were some things I had to modify and do. So I'm just going to go into what I did, what I changed, what I added, and I'm going to do a demonstration of what actually I also discovered something out about the phone itself and just the whole interfacing thing, and some things which may prove useful to anyone trying to do the same thing. To start with, the schematic they have on here, and I'll probably take a picture of this and overlay it on top, but the schematic they have on here, they have 3 basic options. They have an option for a turntable, like a record player connection. They have an option for a tape head, which is what I'd set it up for, and also got a microphone preamp option. So basically it's just different values of resistor for the gain feedback, to change the gain amount and change some of the frequency response for that gain. So in the case of the turntable option, for example, they've got this equalization graph curve thing, which is standard on all record players, I think. So basically what this does is it boosts the low frequencies and cuts the high frequencies, because when you're recording vinyl record, you can't really have the high frequencies. I mean, you can't have the low frequencies too high, otherwise the groove would just be cut far too deep or too rough or whatever. The excursions on the groove would be too big and it just wouldn't fit, or needle would jump out when you tried to play it back or something, and the high frequencies wouldn't come through. They wouldn't record properly if you didn't have them boosted. So they boost the high frequencies when they record it, and they reduce the low frequencies. So obviously with a preamp you would then have to undo that, so you then have to boost the low frequencies coming out because they will have been reduced in the recording process, and you have to reduce the high frequencies because they were increased with the recording process. And of course that was how this was set up. Not exactly, they didn't have the low boosting option in the feedback, but they did have a sort of a high cut thing where they kind of roll off the high frequencies after about 2 kilohertz, so or something. So when I plugged this in just as it was and tried to play this, it sounded absolutely awful. There were no high frequencies at all, and maybe that would make sense with a tape deck, but with this, it was absolutely awful. So I had to change that. And then there was another problem which I can demonstrate on here. What that was. So, oh yes, and also the gain was far too high. They had the for a tape deck, they had the gain set to about 1,000, just the base gain of that. That was completely ridiculous, and plugging it into the phone, I just got clipping and distortion, and it was just absolutely awful. So I removed the high frequency reduction feedback components, the capacitor and resistor for that. I lowered the gain. I still, however, had issues because of that. That meant that I think there was no high frequency reduction whatsoever. So the op amp could then theoretically amplify any frequency all the way up to several megahertz or something. So any RF noise possibly would be amplified and cause it to oscillate. And I think I was having some issues with instability or thing going into clipping or whatever, because it was amplifying high frequencies, probably just picked up just EMI, that sort of thing. So I did have to put those components back, but I changed the values so that it didn't roll off at 2 kilohertz, it rolled off at 20 kilohertz instead, so you're actually out of the audible range by then, and it'll block the high signals but not the actual ones you want to listen to, but it will avoid issues with high frequency stuff like in the hundreds of kilohertz or megahertz or whatever. I also had to do that because of an issue with the phone itself. When I plugged it into this, I noticed that the background noise coming out of this is actually quite substantial, and it's actually quite a high frequency. And I think that's to do with the headphone driver in this. It's probably, I think a common thing they use is they kind of have like a charge pump sort of circuit or something with some capacitors in there to actually boost the voltage up so that it can send out a higher signal to the headphones, because like I said, the battery in this is only going to be 3.5 volts or so they don't have much to actually power it with. So one option is to do that. The other option is, obviously these things are usually going to be class D as well, so you got all that switching frequency in that. So there does seem to be quite a bit of high frequency noise coming out of the actual headphone jack when you play back some audio, and that was a problem because with earphones or headphones, they're probably not going to be that responsive above say 30 kilohertz or something, and you can't hear that anyway, so it sort of doesn't really matter. But when you plug it into an actual amplifier, preamp here, where you've got an op amp chip that can go pretty high, amplify signals that are hundreds kilohertz, megahertz, whatever, you're going to have a problem because those signals will then be amplified and end up affecting the audio and everything else. So I had to add some filtering components as well. I had to change the input section. They already had some stuff set up for that, but I had to add some extra ones just to get rid of the higher frequencies to solve that problem. And I'll just go to that now, and I'll show you a comparison between the final circuit as I've got it set up and what happens if I just feed the input directly into the op amp and ignore those filters and the feedback components, and I'll show you what I discovered and the problems that I faced. Okay, so I've removed all the input filtering, and I've removed the feedback that reduces the high frequency gain, and I've connected this thing up, this is the scope up to the output of the circuit. So now I'm just going to plug my phone in. You'll see a bit of rubbish come on the screen because the phone is doing some sort of weird jack detect thing. And then it settles down, and we see, what have we got here? So this is just with the headphone output completely off. nothing's playing whatsoever. So if I go to lowest point, 5 microvolts per division, sorry, 5 millivolts, you can see there's a bit of noise there, but it's not huge. It's about 2.5 millivolts of noise, and that's on the output, so it's not like excessive or anything. Compared to an actual signal, if I turn the speakers up, you can't really hear anything. It's perfectly fine. Now if I actually start playing some music, I'll have to turn the it sounds, okay, but I'm not sure if it picks up that well on here. But you see the audio signal is, I don't know, it's kind of fuzzy. It doesn't sound too bad really, but this is not, there's not much going on in that music there, but the signal doesn't look that great. And what's more interesting is if I resume the playback, but now if I turn the volume on the cell phone right down to 0, so that's right off, but it's still playing a file, so the headphone output is still active, but there's no actual audio. If I turn this up, back down to even to 20 millivolts, you can see now we've got this this noise here. So I can see if I can just let's see. Where do I have it? Oh yeah, there we go. So we're at 10 microseconds per division here, and this is 20 millivolts per division on the voltage, and you can see, so that's like what, 80 millivolts peak to peak of some kind of high frequency garbage, and that's not particularly good. So you can understand why this, and possibly even higher frequencies that I can't measure. There's even some like sort of high frequency junk in there. I'm not sure exactly what's this, exactly what frequency this is, but it's quite high. It's above the audible spectrum, and it's it's not insignificant. It's not particularly great, and so you can see where the sort of fuzziness is coming from on the actual track. And I can also demonstrate that with so I just paused the music, and the output should turn off. Yeah, see, when the output turns off, it's like perfectly clean because it's not doing anything. But if I run a signal generator here, just zoom that in a bit. We've got all this kind of jitter, and it's just fuzzy. It's not a clean trace. It's not very nice at all. And yeah, it's hard to sort of, it's really hard to show this accurately because I'm trying to film an analog display. I've had a digital scope, it'd be easier to demonstrate, but you can see the the waveform is not particularly nice, and it's quite sort of crusty and horrible. And then there's some like digital noise there. There's like the when the cell phone's connecting to the cell tower or something. And yeah, it's just not that great. But I'll turn that off, and now I'll reconnect all my filters and everything like that, and I'll show you comparison. of how that looks. Okay, so now I've got the preamp put back to how it was before. I've got all the filtering connected back up again and everything. So I'm just going to plug my phone in. You should see the same. So a little bit of popping there, but you know, you kind of got to expect that. There we go. So everything's perfectly quiet. The phone's not playing anything. If I now play some music again, you can see it may not be immediately obvious from this. Like I said, the idea of filming a CRT is not kind of the best option, but you can probably tell that the audio waveform is a lot sharper, it's more defined, and it definitely does look like a much better waveform. But the result is much more obvious if I go to the signal generator program. So just pause that again. Oh yeah, and if I well, let's go right down to the lowest setting here. If I go back down to 5 millivolts again, have a look at this. The noise is now down to like 1.5, 2 millivolts maybe. And if I zoom this right in, back to what I had it before, like 5 microseconds, there's practically nothing there. Now if I play something, again I need to turn the volume down here. So we're playing the file now, but the volume is right down. If I can sort of have a look there, I mean you can actually see the noise. Maybe it's still there, but before we had like, what was it, 80. I had you could see the spikes. This is on the 20 millivolt division scale. You could see the spikes going up to 80. You know, 4 divisions. You could see 80 millivolts peak to peak, or even more. And now when I go right down to even the 5 millivolt scale, you know, the thing is barely above, like say 3 millivolts peak to peak. I can't see anything higher than that. So it's definitely reduced like all that background garbage. So everything above, like, you know, this is, I think I calculated as, it ranged between sort of like 40 to 60 kilohertz or so, and of course there may be components in that are even higher. So without that filtering, the op amp could become unstable or start oscillating or something. So it's just not great to have that there. Oh, my camera battery's about to go flat. But if I go back out to the go back out to the 200 millivolt scale, and I run the signal generator again, you can see, sorry, look how clean that is, and I can trigger off it, much cleaner. Let's turn it up a little bit. I mean, there you go, that's so much nicer than it was before, and there's no jitter, nothing's going to and fro. The trigger is working as you'd expect, and it's just so much cleaner, so much sharper trace. So you can see that, you know, the effect that this has on the audio quality is pretty substantial. So that high frequency, like 60 kilohertz garbage, was just messing up the audio signal quite a bit. And yeah, so that's it's definitely a big difference. I'll just put the two pictures side by side so you can see the sine wave with the filtering and without it, and it's pretty obvious. I'll just turn that off, it's a bit annoying. But yeah, it's certainly a big improvement. And again, the music, the audio signal there is a lot cleaner. It looks far nicer. So interestingly enough, I never had this problem with the iPod. I have an iPod Nano that I tried with this as well, and this like background noise is just not there to begin with. So it's just cheapness of the cell phone output. And I tried 3 different cell phones, and they all had the same problem, just excess background noise. Okay, so here's the updated schematic. Most of it's original, just as they had in the kit design, but I've added some things and changed some things, and I'll just go over how everything works. So this is obviously for just one channel of the amplifier. This is duplicated between both channels because it's stereo. The input, you've got just standard input. And then I have this here. Well, I don't actually have this on the board, but it's something I'll probably add in when I build it into a case. The idea of having a 100 ohm resistor that's switchable in and out as a sort of a dummy load. Now, I have read on the internet that some devices need a sort of a minimum low impedance load to sort of simulate headphones, or otherwise you get severe distortion. They're just not designed to run open circuit or into a high impedance input. Apparently it doesn't work. I didn't have a problem with anything I tried myself, but it's a thing to put there. And also it would be possible to switch that on before you plugged something in, and you wouldn't get any sort of popping noise. I mean, it's hard to sort of avoid that because this is set up to gain of 100 times, and you could add a volume control, I guess, and effectively do the same thing as this, just to sort of turn the signal down, or you can turn it down on your main amplifier. It doesn't really matter. So this is kind of an optional thing that you may or may not want to have if you're doing something like this. So then we've got the input filtering stuff, and we've got the... So this is from the kit, basically. They had like a ferrite bead with 4 turns of wire around it. They don't specify what the inductance is or anything. I don't know what it would be, but it's just like a filter there and a 100 picofarad capacitor ceramic to ground. So this is they say it's for filtering out any RF noise that's picked up by the input leads, and I suppose it does that. It makes sense. I didn't test for that or anything, but it seems to function, so it doesn't seem to affect anything, so I left it there. Makes sense. And then the next bit is this filter that I've added myself. So this is a 820 ohm resistor and a 10 nanofarad capacitor, another ceramic. So this acts as another sort of low pass filter, so it rolls off some of the high frequencies above 20 kilohertz. So it's sort of the same thing as this, but it's just lower frequency. So that will attenuate the high frequency noise coming out of the cell phone and coming into here. Like I said, that's 66 kilohertz. Switching frequency from the phone, from whatever that is, that this filters that out to some extent. And then we got the DC input blocking capacitor. So this was originally 47 microfarad in the original design, and they did say in the kit notes that you could have this as low as like 470 nanofarads, and it would still be acceptable for audio. The reason why they made it 47, they said, was to provide extra loading for like a turntable cartridge in that. So apparently if you're using that, you would want the 47 microfarad one. I found that while using a 47 microfarad, I got, there's an even louder click and more noise when you plug something in. So in terms of just I don't know, making it sound nicer, I just reduced this to 2.2, which is the lowest sort of bipolar cap I had. I don't have any 470 nanofarads at the moment, but I might try replacing it with one of those just to see if I could reduce any pops and stuff even more. But 47 is fine. It doesn't make any difference to like the audio quality, but I just figured putting a 2.2 just seemed a bit better, so that's what I've done. And then R3, this was originally a 100k ohm resistor in the design. I put this down to 10k. It's probably kind of irrelevant what it is, just so long as it's there. They said that with sort of this sort of circuit, the lower the resistance value of this, the less noise will be generated in the amplifier. So I put it down to 10k, and it also reduced these resistors as well. So sort of reducing this made sense. Apparently that's the sort of thing that you should do. I'm not entirely certain as to exactly why, but there you go. Anyway, this resistor is actually needed because of this capacitor. Otherwise this node would basically be floating. There'd be no reference to ground. What would happen eventually is that after an audio signal coming in for whatever amount of time, this capacitor will eventually charge up and basically become full, and then it will just block everything, and then this node will be completely floating, and the op amp will just the output will just swing to positive rail or something basically, and nothing will work. So and interestingly enough, it's apparently possible that this could happen over a period of hours without this here. So you may not even notice it. If this was like a JFET op amp with a very low input current, it could take a lot, and this was a 47 microfarad or even larger or something. It could take a very long time for that to actually charge up and cause a problem. So and I did actually have that issue because I'd taken this resistor out as part of my experimenting and forgot to put it back in, and I actually encountered that issue. So this thing basically the audio would just eventually fade away to nothing after a certain amount of time. So it was so this resistor definitely has to be there for that. Obviously if you didn't have this capacitor you wouldn't need this, but hey, there you go. Then you're not going to have any DC blocking, and you probably don't need like a DC blocking cap in this input necessarily, because the output from the headphone output of your phone should have no DC on it anyway, unless it's faulty or something, or if they're doing some sort of, well, depending on how they drive it, I guess. But yeah, I mean, you should really have this there, so you need this resistor. But if you weren't using this, then you probably wouldn't need this. But hey, so then we have the op amp LM833. This is what came with the kit. It seems to sound perfectly fine to me. It's not probably the best one you could get, but hey, it seems to work perfectly fine for this, so that's what that is. And then this feedback resistor here, and these parts here. So we've got 20k here and a 200 ohm here. So basically, for the most part, the gain is set at 100 times with these two resistors. I chose 100 because that seemed to be the optimal gain setting that allowed me to run my phone at about the same volume that I would with headphones, and have my amplifier at the same volume that I would with everything else. So that made it the most convenient, which was the entire point of this project. But this resistor and this capacitor here, that's similar to what they already had in the circuit originally. In fact, the 3.6k is the same. But I increased this capacitor. I think they originally had a 22 picofarad, so I increased that to 270 because the original circuit rolled off the high frequencies above like 2 kilohertz, which wasn't particularly useful because then it made everything sound like crap. Obviously, if you're using a turntable with that, it would make sense. Like I said, with the equalization curve, you have to have that. But with a flat frequency response from an actual MP3 file or whatever, it's not necessarily. It would just make everything sound terrible. So I changed this to 270. Probably like 200 to 300 would be fine, and this just means the gain just starts rolling off after 20 kilohertz. So this will reduce the gain of those high frequencies, and this will also filter them out to some extent. So both of these parts of the circuit work together to reduce anything above 20 kilohertz, basically. So as you could see on the oscilloscope, that 60 kilohertz, switching frequency coming out of the phone was basically just almost gone. It was just down in like the noise floor of the headphone output itself. So that seemed to work pretty effectively. And then this capacitor here is apparently used to stop the op amp from amplifying any DC offset. Again, like there probably shouldn't be one anyway, but the kit says that's what that's for. So I thought, well, I'll leave it in there. Why not? It doesn't seem to hurt, and why bother going to the effort to take it out when it seems to be fine. And then we've got this 100 ohm resistor on the output. Apparently, now these components are not really explained in the kit manual. The 100 ohm resistor, as far as I can tell from my research, is there to provide stability for the LM833. Some op amps probably wouldn't need this, but apparently it increases stability to have this load there. So yeah, I don't know. maybe that's why, maybe not, but I left it there because it's stability is a good thing, and I think that is what it's for. So yeah, I just left it there. Then we got a 33 nanofarad. Was it 330? I might have done that wrong actually. Anyway, this again with DC blocking capacitor on the output, and it also helps reduce really low frequencies, like below 9 hertz, I think. So I guess if you're using a subwoofer, if you wanted to have this driving a subwoofer or something, you'd probably want to increase the value of this capacitor to avoid blocking those frequencies or something. But for general use, it's sort of fine. And again, just leaving it there is less effort than taking it out and changing it and mucking around. So for just standard stereo speakers and a standard system, I don't think it's a problem to have that there, reducing those really, really low frequencies. I mean, if you have like some massive subwoofers or something, then you'd probably want to change this to something bigger so that it doesn't block them as much. But yeah, that's what that's for, apparently. And this 1 mega ohm resistor is probably providing the same sort of solution as this one is doing, so that your input to your amplifier doesn't end up floating the same way this would, just in case the input to the power amp is doesn't have a resistor like this or whatever. So you don't have the same problem here. I think that's what that's for. There's no explanation in the kit as to what that's there for, but that's just my guess. Anyway, so yeah, or just to discharge this, when you turn it off or something. But yeah, that's pretty much what it is. So yeah, the significant thing to note for me was to add change these and basically add this capacitor here to reduce those high frequencies, and again this filter here to reduce the high frequencies, because that digital sort of noise coming out of the cell phone was a big problem. And then I reduced the gain, like I said, to 100, because anything above that didn't really make sense. And as you can see, the resulting waveform is much cleaner and much nicer, and as far as I can tell from my testing it all day yesterday, didn't have any issue with instability or clipping or anything. So it looks like the circuit is working basically as optimally as I can make it with what I got to work with. So yeah, that's seems to be pretty good now. But yeah, if you want to make your own version of this, it's pretty simple. Obviously I haven't shown a power supply here, or there's also obviously decoupling capacitors for the power rails for this op amp, but it's pretty simple. And you can use whatever op amp you want. I mean, as part of my testing I switched it out with a TL072 and it sounded just as good. So yeah, I mean, it's not like a, some people would say the TL07 series is not the best op amp for hi-fi, but I mean you can clearly see, going by the scope waveforms and that the audio output from the headphone jack of a cell phone is not hi-fi to begin with. It's not it's not good quality. So I think anything like a LM833 or higher quality is you're going to be fine with that. There's no sense in going anything better than that unless you're plugging this into a high quality source. So a cell phone is not a high quality source. That's probably the lowest quality thing in the whole chain, and yeah, it's not like there's any point. So yeah, you can build this with whatever amp. You can probably use a 741 and it would probably sound just as good. But there we go. With a few modifications, I was able to turn this thing into a pretty decent little preamplifier that does what I need to preamp the audio from my cell phone. So I guess this does go to show, though, that the quality of the audio output from cell phones is not particularly great. And it's kind of not surprising, because, compromises with size and voltage levels and stuff and what they have to do to actually squeeze a decent headphone output into something like this. But yeah, it definitely shows that if you want to do something like this, it may be an issue. And I did notice this problem with 3 different cell phones that I tried, and yeah, so it's probably quite a common thing. I don't know, I don't think many cell phones are actually sold on their audio quality. I don't know if any, to be honest. But I mean, this is a pretty, this is a BlackBerry. It's a pretty respectable brand, I guess. It's not some like unknown thing from the middle of nowhere. So you'd expect something like this to be fairly decent, and that a Huawei and a Motorola, that kind of thing. They're all like big names, but all of them have this issue. So I don't know. It may be just something inherent in cell phones. I mean, my iPod Nano that I tried actually, didn't have this problem at all. The audio was just perfectly clean to start with. So, yeah, but I mean that's a purpose-designed audio product, and you would expect it to be a lot better quality. But yeah, I guess headphone outputs on phones are just cheap. But if you employ the filtering techniques like I used here, it seems to solve the problem. So I mean, I have had this hooked up to my stereo as it is, and it sounds fine to me. I don't notice any problem, and like I said, the waveform is clean, everything is nice. So yeah, I'm happy with it. I think this is pretty much done now. It's all working how I'd expect. I need to build this into a case. Obviously, I've got a case for it, which I'll put it in eventually. I do need to get like a main switch and fuse holder and all that kind of stuff for the the main power supply. Got a little transformer in that, all that kind of stuff. But yeah, so that'll happen eventually. Not sure exactly when. Have to, whenever it happens, it'll happen. But yeah, I was just sort of getting this circuit to actually function properly and sound good and deal with this issue. And originally, I actually thought it was the circuit itself was just not that great, but turned out it was actually the cell phone itself that wasn't that great. So yeah, there you go. So anyone mucking around with cell phones, preamps, hopefully could get some information off that. And yeah, well there we go. It seems to be all working. So yeah, hopefully that was enjoyable and hopefully it's useful. And I'll see you next time.